Hello everyone, so let's discuss today's POTD, that is 2257, count unguarded cells in the grid. So it is marked as medium. You are given two integers m and n representing a zero indexed m cross n grid. You are also given two 2D integer arrays, guards and walls, where guard I is equal to row and column I, and walls is equal to row j and column j. Represent the positions of ith guard and jth wall respectively. A guard can see every cell in the four cardinal directions, that is northeast, southwest, starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells that are not guarded. So what the problem statement is saying that you are given a 2D matrix, and in each cell there is a guard, or there is a wall, or there is an unoccupied cell present. So you have to tell the unoccupied cell at the last that are present, such that it cannot be seen by any guard, and it is not obviously not a guard or a wall cell. So guard, where can the guard see? Guard can see in the four direction, that is east, west, north or south. So let's understand it with the example test cases. So the first example is given M4 and N6, and guard are present in this cell 0, 0, 1, 1 and 2, 3, and the walls are present on 0, 1, 2, 2 and 1, 4. So this guard can see top means up, left, right and bottom. So this can see only bottom because this is obviously this will be out of the matrix, that is not possible. And this guard can see its left, right and down. Also this guard can see up and down and right. So these all red marked cells can be seen by the guards, while these yellow marked cells are unoccupied cells. So we have to return the count of unoccupied cells, that is 1, 2, 3, 4, 5, 6 and 7. So the answer will be 7. So the first approach that came in the mind is the brute force approach. So we have to just simulate same that the question saying us. So what we are doing, first we will create this matrix and we will mark these guard and walls. So I've created a matrix of m cross n size and initially marked it as a 0, means all cells are unoccupied. Then I'm marking the guard cells with 1, means 1 for the guard, and marking the two wall cells with the 2. That is, if the cell contains 2, that means the wall is present in that cell. Now I'm traversing in the matrix. What I'm doing is, if the current cell is my guard, then I am checking its all four direction and marking the all four direction to the that guard can see. So I'm using 3 to mark the cells that can be seen by the guards. So I'm traversing all the four direction of the current guard cell where the guard is present. So this for loop is for the right, checking the to the right of the current cell. This is for the left, this is for the down, and this is for the up. So like this I am checking for all the cells, means let's understand it with this example. Suppose I am at the 0, 0, and if my v of 0, 0 is equal to 1, means I have a guard in this cell. Now I will check for the right, for the down, for the left and for the up with these for loops, with these four for loops. Then at last I am just counting the unoccupied cells, means if my cell contains 0, that means this is not occupied by any of the guard, this cannot be seen by any of the guard and not occupied by guard and the wall. So at last I am returning count. So the time complexity for this approach is we are taking m here, cross n here, m cross n here, and this will take m plus n, approximately m plus n. So the overall time complexity will be O of m cross m plus n, and the space complexity will be m cross n because we are making this grid. Yeah, so this was the solution for this problem. Thank you.